This is going to be an answer key or a video where I work out the problems which are on the review for test number 4, which covers units 7 and 8. And before we get started, I want to mention to you that a lot of the questions on this particular test are going to require you to use the formulas for double angles, half angles, the sum and difference formulas for sine, cosine, and tangent. So you may want to either create your own or print off one of the ones that is provided in the course that has the formulas listed out and have it nearby as you are working through the problems, and also have it nearby as you are actually taking the actual test 4 exam. I also would encourage you to have the trigonometric identities close by, whether that's the cofunction, the quotient identities, the reciprocal identities, or the Pythagorean identities, because you're going to need those as well on this particular test. So again, you can either print off one that's provided or create your own. That way you're not fumbling around trying to locate those as you're working through the problems. So let's get started. The first few problems on this exam are related to the trigonometric identities and basically your ability to manipulate those or use substitution, replace one for the other, to simplify or write an equivalent expression. And this skill becomes important, especially as you move into calculus, because if you have something complicated like question number 1, which is cotangent squared x plus 1 over secant squared, perhaps you can simplify it where you have only one trigonometric function involved, or where you don't have a sum like plus 1 or anything like that. So we want to utilize the trigonometric identities. And one of the things that jumps into my mind as I look at this is since it's squared, I'm thinking about the Pythagorean identities. And if I go out and look at my Pythagorean identities, there's one that involves the relationship between cotangent and cosecant. So 1 plus cotangent squared, or cotangent squared plus 1 would be the same as the cosecant squared. So I can perform a substitution. We know that, let me get my pen working here. Okay, so we can draw. We know that cosecant squared x is equal to cotangent squared x plus 1. That's one of our Pythagorean identities. So we're going to use that and we're going to substitute into cosecant squared x over secant squared x. Now you may think, well, that didn't really help me because we still have two trig functions, but it does help me in the sense that I no longer have the sum. I don't have cotangent squared plus 1. I have just a single trigonometric function. From there, I'm probably going to convert into sine and cosine. Okay, so cosecant is 1 over sine squared. I'm using the reciprocal identity. And secant is 1 over cosine squared x. So then I have a fraction, and remember that fraction indicates division. So we divide fractions, we flip and multiply. So this becomes 1 over sine squared x times cosine squared x over 1. Remember, you flip and multiply. We multiply, we get cosine squared x over sine squared x. And if you'll recall, with the quotient identity, that cosine over sine is cotangent. and it would be cotangent squared. So cotangent squared x plus 1 divided by secant squared simplifies to cotangent squared x, which would be much easier to deal with if I needed to take the derivative or find the integral of that trigonometric function as we move into calculus. Okay, so moving on to question number 2. Again, you're trying to rewrite this expression cosecant squared x minus 1 divided by cosecant squared x. You're trying to rewrite that and simplify it. You may go, well, okay, we've got the a single trigonometric function. Well, that's okay, but it does involve a fraction. So I want to see if I can simplify that. Now, if I go back, we just saw that cosecant squared x equals cotangent squared x plus 1. Well, if I solve this for cotangent, whoops, sorry, got ahead of myself there. Okay, if I solve this for cotangent, I have cosecant squared x minus 1 equals cotangent squared x. So this expression on the top, cosecant squared x minus 1, is equivalent or is the same as cotangent. So I can rewrite this as cotangent squared x over cosecant squared x. And then I'm going to convert to sine and cosine. If nothing else, when you're working these problems, convert everything to sine and cosine. Cotangent would be cosine squared x over sine squared x. And cosecant is 1 over sine squared x. So again, now I still have a fraction divided by a fraction. So we're going to flip and multiply, or take the reciprocal and multiply. Cosine squared x over sine squared x times sine squared x over 1. So if we multiply that out, and I'm going to multiply it out so you can see really what's happening, you're going to have cosine squared x times sine squared x divided by sine squared x. Well, notice that you have a sine squared x in the numerator and the denominator, which will divide out, and you're left with cosine squared x over 1, which is simply cosine squared x, which is going to be a whole heck of a lot easier to deal with than cosecant squared x minus 1 all divided by cosecant squared x. Again, we've eliminated the fraction and we have a single trigonometric relationship. All right, moving on to number 3, it says which expression is equivalent to cotangent squared beta times 1 minus cosine squared beta. Now there's always different ways to solve these problems. Sometimes it's a matter of what kind of pops into your head first. What pops into my mind is this relationship here. One of the primary relationships with the Pythagorean identities is that cosine squared plus sine squared equals 1. If I solve this for sine squared, I see that sine squared beta is 1 minus cosine squared beta. So I can take this difference, 1 minus cosine squared beta, and replace it with sine squared with the equivalent, which is sine squared. So I would have cotangent beta times sine squared beta. Then again, I'm going to use the idea of converting to sine and cosine. So I would have cosine squared beta over sine squared beta times sine squared beta over 1 if you want to make it a fraction. And so then when we multiply that, we have cosine squared beta times sine squared beta over sine squared beta. And again, notice at that point that you do have a sine squared beta in the numerator and the denominator, which will divide out. So you have cosine squared beta over 1, which simplifies to cosine squared beta. And there's your answer. Okay, moving on to question 4. Question 4 says, given that cosine A equals negative 4/5 with angle A in quadrant 2 and sine B equals negative 24/25 with angle B in quadrant 3, find sine A plus B. Okay, now a couple of things are important here. First of all, I know that I'm ultimately looking for the sine of A plus B. So probably the first thing I want to do here is write down my formula. So the sine of A plus B is the sine of angle A times the cosine of angle B plus the cosine of angle A times the sine of angle B. So I'm given, if I think about what I'm given in this problem, I'm given cosine A and I'm given sine B. Okay, but I also need the sine of A and the cosine of B. So I have to do a couple of preliminary steps. Okay, so if you want to think about it as steps, in step 1, I need to find the sine of angle A. So to find the sine of angle A, I'm going to use my Pythagorean identity. That's the easiest way to do it. Okay, you have cosine squared A plus sine squared A equals 1. Cosine squared plus sine squared equals 1. And it is important that angle A is in quadrant 2. We'll talk about that in just a minute. Okay, so if I do this substitution, I know that cosine of A is negative 4/5 squared plus sine squared A equals 1. Negative 4/5 squared, negative 4 times negative 4 is 16. 5 times 5 is 25 plus sine squared A equals 1 whole. Then I'm going to subtract the 16/25 from either side. Okay, I'm going to run out of space, so I'm going to take it up over here to the side so that I have sine squared A equals. Okay, so you have 1 whole. You have to remember you're going to need to find common denominator. If I have 1 whole pizza that has 25 slices, that's 25 out of 25. So 25 minus 16 is 9 over 25. But that represents sine squared. So then I need to take the square root, and when you take the square root, it could be positive or negative. So I have the sine of A equals square root of 9 is 3, square root of 25 is 5. Now, we know that angle A is in quadrant 2. If you think about your coordinate plane, in quadrant 2, your x value is negative and your y is positive. The sine corresponds to the y, so it should be positive. So here is my value for sine A. So now I know sine A. Step 2 is I've got to find the cosine of B. Okay, and I'm going to have to see if I can get me some more space in here, so hold on just a minute. Let me see if I can make some more space. Well, let's see. Okay, so step 2 here is to find cosine B. And I'm going to do the same thing. I'm going to use cosine B plus sine squared B equals 1. I'm going to use that Pythagorean identity. I'm told in the original problem that sine B is negative 24/25 and B is in quadrant 3. So I would have cosine squared B plus negative 24/25 squared equals 1. So I have cosine squared B plus, and I'm going to use my calculator, negative 24 times negative 24 is 576. 25 times 25 is 625, and that equals 1. I'm going to subtract the 576 over 625 from either side. Again, trying to isolate, in this case, cosine squared. So I have cosine squared B equals, again, be careful, make sure you find that common denominator. 1 whole would be 625 over 625. So 625 minus 576 gives me 49 over 625. And then I need to take the square root of both sides. Again, it could be positive or negative. So I have cosine B equals 7 over 25. In quadrant 3, where angle B is located, again, thinking about your coordinate plane, it is negative, negative, negative x, negative y. Cosine corresponds to the x, so my answer should be negative. Okay, so there's cosine B. So now I have all of the information that I need to plug in, and I'm going to write it down here so we don't lose track of everything. Okay, so we were told in the original problem that cosine A was negative 4/5. We determined that sine A was positive 3/5. We were told that sine B was negative 24/25, and we've determined that cosine B is negative 7 over 25. And we're going to plug into the sum and difference formula. Okay, so I would have the sine of A plus B equals the sine of A times the cosine of B plus cosine A sine B. Okay, helps to write the formula down, and then it becomes a plug and chug. You plug the numbers in. So sine of A is 3/5. Cosine B is negative 7 over 25 plus cosine A is negative 4/5 and sine B is negative 24/25. Then you got to do the math. 3 times negative 7 is negative 21 over 5 times 25 is 125 plus negative 4 times negative 24 is positive 96 over 125. Then we have a common denominator, so we keep the denominator. We're going to do the addition. Negative 21 plus 96 in the numerator gives me 75 over 125. And if we simplify that, we get 3/5. Okay, so the answer, sine of A plus B, would be 3/5. Okay. It is a lengthy problem, guys. You have to be careful, okay, and watch your numbers, but it'll help you if you'll write the formulas down as you go. Okay, this one says using the unit circle. So you'll want to have your unit circle nearby, okay, when you're doing this. And we want to do the sine of 4 pi thirds plus pi fourths. Okay, so you can call it A and B or X and Y. So the sine of X plus Y would be the sine of X, excuse me, got carried away there, sine of X cosine Y plus cosine X sine Y. And we're going to get these numbers from the unit circle. And I believe I have a unit circle on one of my formula sheets here. No, I don't. Let me pull it up. Let me find my unit circle. Okay, because you want to have yours nearby. Okay. There it is. Okay, so we need to find 4 pi thirds. So I'm looking at my graph at 4 pi thirds. The sine is negative square root 3 over 2. Okay, so I'm going back over here. The sine of 4 pi thirds, so this would be the sine of 4 pi thirds times the cosine of pi fourths plus the cosine of 4 pi thirds times the sine of pi fourths. It may help you to put those numbers in there. Then you're going to read these from the unit circle. We just said the sine of 4 pi thirds is negative square root 3 over 2. Then I go back to the unit circle and I look for pi fourths. Pi fourths, the cosine is square root 2 over 2. Okay, so I've got square root 2 over 2 plus the cosine of 4 pi thirds was negative 1/2. And the sine is square root 2 over 2. Again, you pull those directly from the unit circle. Then you perform the multiplication. Negative square root 3 times square root 2 is negative square root 6. 2 times 2 is 4. Plus negative 1 times square root 2 is negative square root 2 over 2 times 2 is 4. Again, you have that common denominator. You can't add the numerator because they're not like radicals. So you have negative square root 6 plus negative or minus square root 2. The answer would be negative square root 6 minus square root 2, all divided by 4. That was a little bit easier because you're using the unit circle. Okay. Now, let's go to number 7. Number 7 is similar to number 5 in that it's going to be those 3 steps because we've got to find all of the missing pieces. This one wants you to find cosine of A, excuse me, A minus B. So again, if I write down my formula, I have cosine of A minus B equals cosine A times cosine B plus sine A times sine B. And if we look at what we're given, In the problem, we're given cosine A as 15/17 and A is in quadrant 4, and we're given cosine B, which is 4/5 and is also in quadrant 4. Okay, but I need sine A and sine B. So again, it's kind of that three-step process. Step 1 is we need to find sine A. We're going to use the Pythagorean identity cosine squared A plus sine squared A equals 1 to do that. Okay, so I know that cosine A is 15/17. So I have 15/17 squared plus sine squared A equals 1. 15 squared, I believe, is 225. I'm going to use my calculator and double check. Yep, it's 225 over 17 squared, which is 289, plus sine squared A equals 1. Whoops. Then we're going to subtract 225 over 289 from either side. So we have sine squared A equals, again, finding that common denominator, 1 whole would be 289 over 289. 289 minus 225 is 64. So we get 64 over 289. And then you need to take the square root of both sides. Remember, it could be positive or negative. So the sine of A equals, square root of 64 is 8, square root of 289 is 17. Remember, angle A is in quadrant 4. In quadrant 4, we have a positive and then a negative. So the y, which is the sine, is negative. So sine of A is negative 8/17. Then we got to go back, start over, and we need to find sine of B. Again, using the Pythagorean identity, cosine squared B plus sine squared B is 1. We're told that cosine of B is 4/5. So I have 4/5 squared plus sine squared B equals 1. 4 squared is 16. 5 squared is 25. Plus sine squared B equals 1. Subtract 16/25 from either side. Remember that 1 whole is 25th, 25, 25th, 25 over 25. So 25 over 25, we have sine squared B equals 25 minus 16 is 9 over 25. Then we're going to square root both sides. Remembering it could be positive or negative. So sine of B equals square root of 9 is 3. Square root of 25 is 5. Again, B is in quadrant 4, and we already decided in quadrant 4 that the sine or the y value is negative. So now I have all of my pieces. We are told from the beginning that cosine A is 15/17, we determined that sine of A is negative 8/17. We're told cosine B is 4/5, and we determined that sine of B is negative 3/5. So then I'm going to use my cosine of A minus B. That was the original problem. Okay, so using my formula, cosine of A minus B is cosine A times cosine B plus sine A sine B. We have all of the pieces, so we're going to plug and chug. So we have 15/17 times 4/5 plus negative 8/17 times negative 3/5. You need to do the math, do the calculations. Okay, so we would have 15 times 4 is 60, 17 times 5 is 85, plus negative times a negative is a positive, 8 times 3 is 24, 17 times 5 is 85. So we have 85 as our common denominator, and then let's see, 60 plus 24 is 84. So we get 84/85. There's our answer. Because you have to be really careful, pay attention to your signs, work it through. Don't try to do a lot of this in your head, because if you do, you're going to make a lot of mistakes. All right, question 8 says, given that cosine B is negative 3/5 with angle B, or beta, excuse me, in quadrant 2, what is cosine 2 beta? So this is a double angle, and again, because it alludes to 2 beta, I know that I'm going to use one of those formulas. Now, the thing with cosine 2 beta that sometimes confuses students is that there are 3 different forms of this particular formula, and so students sometimes struggle with knowing which one to use. Well, you want to try to use the one that is easiest based on the information that you're given. So when I'm looking at this problem, I notice that I'm given cosine beta. Well, I really don't want to use this first formula, cosine squared beta minus sine squared beta, because I don't know sine squared. I don't want to use the second one, again, because I need sine squared and I don't have it. The third option, which is 2 cosine squared beta minus 1, is my best option because it only involves cosine, and it's the one that I was given. So I'm going to use the form of cosine 2 beta. I'm going to use 2 cosine squared beta minus 1. Okay, so I have what I need, and it just becomes a matter of plugging into the formula. So I have 2 times cosine beta is negative 3/5. I'm going to have to square it and then subtract 1. So I have 2 times negative 3 squared is 9. 5 squared is 25 minus 1. Now you have that whole number hanging out front, so you have 2 over 1. Remember, you multiply the numerators, you multiply the denominator. So I have 2 times 9, which is 18. 1 times 25 is 25, minus 1 whole. And again, we've talked about how that 1 whole would be 25th, or 25 25ths, 25 over 25. Finding that common denominator, then I can do my subtraction. I keep the common denominator of 25. 18 minus 25 would be 7, and it's going to be negative. So my answer is negative 7/25. Okay. All right, number 9, again, ask you to find cosine 2 theta, and this time you're given the cosine, or excuse me, you're given that the sine of theta is 9/11 and theta is in quadrant 2. Well, again, you have those three forms, and this time I have the sine squared. So I think I want to use the formula cosine 2 theta equals 1 minus 2 sine squared theta. Again, if you think about those three options that you have, all of the others that you have are going to require you to also know the cosine, and you don't. So we're going to use the one that only involves sine, because that's the value that's given to me, and it becomes a straightforward plug and chug. So I would have 1 whole minus 2 times 9/11 squared. Okay, do the math. 1 whole minus 2 times 9 squared. 9 times 9 is 81. 11 times 11 is 121. Okay, remember to turn your whole number into a fraction. We put it over 1. So this becomes 1 whole minus 2 times 81. Okay, so 2 times 81 is 162 over 121. Find your common denominator. 1 whole would be 121 over 121 minus 162 over 121. So we keep our denominator of 121. 121 minus 162 is negative 41. So our answer is negative 41 over 121 for cosine 2 theta. Okay, number 10, it says given that sine theta is negative 12/13, theta is in quadrant 3, what is cosine 2 theta? Some reason these problems got hung up on finding cosine 2 theta. Again, noting that I have the sine, I'm going to use the relationship 1 minus 2 sine squared theta to find or determine the value for cosine 2 theta. And again, it becomes a straight substitution since I'm given the sine. So I have 1 minus 2 times negative 12/13 squared. So I have 1 whole minus 2 times negative 12 squared. Negative 12 times negative 12 is 144. 13 squared is 169. Again, be careful. Make sure you turn your whole number into a fraction. So you have 1 whole minus 2 times 144 is 288 over 169. Whoops, sorry. Then you need to find that common denominator. So I would have 169 over 169 minus 288 over 169. You have that common denominator of 169. Do the subtraction. 169 minus 288 equals negative 119 over 169. Now, these are fractions, so if you need to, you want to make sure you simplify the fraction. This one does not, but should you be asked to, make sure you simplify your fraction. So the answer is negative 119 over 169. Okay, number 11 alludes to the half angle formula. Okay, so it tells you you're going to use a half angle formula. We're doing cosine, and it tells us here, there's a little typo there, guys, that 165 degrees is 330 degrees divided by 2. Now that's important because I need an angle that's on the unit circle. So for these problems, most likely you're going to be using the unit circle. Okay, so I need the half angle formula for cosine. So the cosine of theta divided by 2 is plus or minus the square root of 1 plus the cosine of theta all divided by 2. Now, in this problem, again, you got to put it in the context. Okay, we're looking for 165, so the cosine of 165 degrees equals the cosine of 330 degrees over 2. Your theta, the angle that you are interested in, is 330. That's the one you're going to read off of the unit circle. Okay, so be careful, make sure you're reading the right angle. Okay, so we have plus or minus the square root of 1 plus the cosine of 330 degrees all divided by 2. And then from my unit circle, I'm going to read what the value is for the cosine. So I would have plus or minus the square root of 1 plus, I'm going to look up that value, all divided by 2. Okay, so going out to my unit circle, finding 330 degrees, and I need the cosine. The cosine is square root 3 over 2. So I'm going to have square root 3 over 2. Now guys, this is going to be really messy for a minute because you have a fraction, an overall fraction, but now you also have a fraction in the numerator. So we're going to focus on, for just a minute, 1 plus square root 3 over 2. In order to add that, you have to have that common denominator. So we would have 2 over 2 plus the square root of 3 over 2. We found that common denominator. But I cannot literally add 2 plus square root 3 because they're not like terms. So I have plus or minus the square root of 2 plus square root 3 all over 2, and then that yucky looking fraction is divided by 2. So we actually have here a fraction divided by a whole number, and we simplify that by flipping and multiplying. So we're going to have 2 plus square root 3 all over 2 times, remember this is 2 over 1, you're going to flip it, it becomes 1 over 2. So then if we do that multiplication, again, this is messy. This is a lot of algebra that you have to do here, guys. You got to get the math going on. Plus or minus the square root of 2 plus square root 3. 1 times 2 is 1. 1 times square root 3 is square root 3. Over 2 times 2 is 4. And I am almost home free at that point because I'm going to break this apart. The square root of 2 plus the square root of 3 all over square root of 4, which is 2. Now, guys, the very last thing that I have to do is I have to decide whether this thing should be positive or negative. So I'm going to go back to my unit circle. I'm looking for a 165-degree angle. So if you think about it, a 165-degree angle is going to be somewhere in quadrant 2. In quadrant 2, the cosine is negative for whatever angle you have. In quadrant 2, the cosine is negative. So ultimately, my answer here has to be the negative square root of 2 plus square root 3 all over 2. It's messy, but this is the answer. And guys, what's important is that is the exact answer. If you just plugged cosine of 165 into your calculator, you're going to get a decimal. And sometimes decimals are okay. But guys, if you're building bridges or building airplanes, it matters and you have to be exact. All right. Question 12 again tells you specifically to use a half angle formula, and this time we want tangent, and we want tangent of 5 pi eighths, and it tells us that 5 pi eighths is 1/2 times 5 pi fourths. So for tangent, here again with tangent, you have half angles, you have 3 different formulas, and I'm going to write them all down here, and we'll talk about which one I would recommend that you use pretty much all the time. Okay, so one option is you have plus or minus the square root of the quantity 1 minus cosine divided by 1 plus cosine. Well, guys, that's messy because I got a radical. The second option is sine theta divided by 1 plus cosine theta. There's no radical, it's still a fraction, but the other thing is you've got that sum, that 1 plus cosine theta in the denominator, and as opposed to just a plain old single term. The last formula is 1 minus cosine theta over sine theta. I would strongly recommend that you use this third option. 1, it has no radical. 2, you're not going to have to decide between positive and negative. 3 is it has a single term in the denominator. There's no addition or subtraction. It's just one plain old term. So I would use this formula. So if I'm going to use that one, then I would strongly recommend that that be the one you use pretty much all the time for tangent. Is I have tangent of theta over 2 equals 1 minus cosine theta over sine theta. Now here again, thinking about what theta would be, we have tangent of 5 pi eighths equals the tangent of 5 pi fourths divided by 2. Your theta in all of this is the 5 pi fourths. So I would have 1 minus the cosine of 5 pi fourths divided by the sine of 5 pi fourths. And again, those values for cosine and sine are going to come from your unit circle. So let's see. 1 minus, and I'm going to go over to my unit circle and find 5 pi fourths. See, 5 pi fourths. The cosine is negative square root 2 over 2, and the sine is also negative square root 2 over 2. So I would have minus . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . negative square root 2 over 2 divided by negative square root 2 over 2. Again, this is going to get messy for a minute because you got to do the algebra manipulation and solve this. Okay, so we would have, again, our 1 whole becomes 2 over 2. So we have 2 minus a minus is a plus square root 2 all over our common denominator of 2 divided by negative square root 2 over 2. So you basically have a fraction divided by a fraction. To do that, we're going to flip and multiply. Okay, so we have 2 plus square root 2 all over 2 times 2 over negative square root 2. Okay, then I'm going to do a little bit of simplification here. I notice that I have a 2 in the denominator and a 2 in the numerator. So I have 2 plus square root 2 all over negative square root 2. If you remember your rules from algebra, you are not permitted to have a radical in the denominator. So I need to multiply the numerator and the denominator by that radical. Okay, so when I do that, I have 2 square root 2 plus square root 4, square root 2 times square root 2 is square root 4, over negative square root 4. And again, I'm writing out all the steps. Some of you may be able to do some of those calculations in your head. So I have 2 square root 2 plus 2, square root of 4 is 2, over negative 2. And then I realize I have square root 2 over 2 divided by negative 2 plus 2 over negative 2. I'm going to break it apart so that I can ultimately simplify this fraction. 2 over, I have a 2 in the numerator, a 2 in the denominator. There's a negative there, so I have negative square root 2. 2 divided by 2 is 1, and it's negative. So I end up with my final answer is negative square root 2 minus 1. But again, guys, it takes a good while to get there. You got to be careful. Okay? You got to be careful in getting there because it's a lot of math. All right, question 13 says if cosine theta is negative 15/17 and theta is in quadrant 2, then what is the sine of theta over 2? Okay, so this one, again, they're asking you to do the half angle, and the sine of theta over 2 is plus or minus the square root of 1 minus the cosine of theta all divided by 2. So to plug into this formula, I need cosine theta, but cosine theta is given to me. Okay, so again, at this point, this one is reasonably straightforward, and I'm simply going to do the substitution. So I would have plus or minus the square root of 1 minus cosine theta, I'm told, is negative 15/17 all divided by 2. So I have plus or minus the square root of 1 minus a minus is a plus 15/17 all divided by 2. So plus or minus, and I need to add those things in the numerator together. So remember, 1 whole is 17/17. So we have 17 as our common denominator, and 17 plus 15 is 32. So we have 32/17 divided by 2. So we have plus or minus 32/17 times, remember flip and multiply, 1/2. So that becomes plus or minus the square root of 32 over 34. So we have plus or minus square root 32 over square root 34. Again, we have the issue of having that radical in the denominator. So I have to multiply the numerator and the denominator by square root 34. So I'm going to end up with 34 in the denominator. 32 times 34, that's a pretty big number, so I'm going to try to break those down first. 32 is 2 times 16. 34 is 2 times 17. Well, I know that 16 is a perfect square, which is going to give me a 4. Then I have a pair of 2's, so it's going to come out. So I end up with 8 on the square root of 17. Okay, if you want to multiply those two together, 32 times 34 is 1,088. And 1,088, excuse me, 1,088 divided by this would become 64 times 17. 64 is a perfect square, which is 8. Then I notice that the numerator and the denominator can be divided by 2. 2 goes into 8 4 times. 2 goes into 34 17 times. So we end up with 4 square root 17 over 17. But I still haven't dealt with my plus or minus. Okay, so I need to think about whether this is going to be positive or negative. So if I have angle theta in quadrant 2 and I cut it in half, then I'm going to end up in quadrant 1. Okay, I'm going to end up in quadrant 1. So theta divided by 2 is going to end up in quadrant 1, and in quadrant 1 the sign is positive. So our answer should be, I'm going to emphasize it here, positive 4 square root 17 over 17. That's usually the biggest mistake students make. If they can get through the algebra, they miss getting that sign. But think it through. If cosine theta is in quadrant 2 and you divide it in half, you're going to go backwards and end up in quadrant 1 where the sign is positive. Alright guys, I'm almost through. Number 14, you begin to be asked to solve equations. And one of the things you have to pay really close attention to when you're solving these equations are your limitations. They want your answers here to be between 0 and 2 pi. Notice that 0 is included, but the 2 pi is not. It's important that you pay attention. It's also that they ask for the answer in radians, not in terms of degrees. So that means you want to pay attention to your calculator mode. Okay, if you have to do these where you use your calculator, you want to make sure you pay attention to your calculator mode. But most often we're going to use the unit circle. So I have 2 cosine theta minus 3 equals -5, and I'm trying to solve for cosine. So first I'm going to add 3, good old basic algebra, add 3 to either side. I have 2 cosine theta equals -2. Continuing to do my basic algebra, I'm going to divide by 2 on either side. So cosine theta equals -1. Now, what we're really doing here at this point then is we're going to use the arc function. We're going to use the arc cosine of both sides. So theta equals the arc cosine of -1. And when you see that, basically what you're being asked is where on the unit circle does the cosine equal -1? Okay, when you see this expression, you're being asked where on the unit circle does the cosine equal -1. Okay, so if I go out to my unit circle, and cosine corresponds to the y coordinate, and the cosine is -1 at pi. So my answer would be here that theta equals pi. Now I want to double check, but I believe that's the only location on my unit circle where the cosine is -1. The other thing I want to check is to make sure that my answer is between 0 and 2 pi, and it is. So I'm okay. So my answer is theta equals pi. All right, number 15. Again, it's asking you to solve the equation, but pay attention. Your answer should be between negative pi and positive pi, and it asks you, you can include negative pi, but not positive pi. And we're doing tangent, okay? And so I noticed first off that, and again, it needs to be in radians. So I have a common factor of 5 and a common factor of tangent. So I'm going to factor out 5 tangent theta. That leaves me with tangent theta plus 1, and that equals 0. So then I know that one of those pieces, I don't have to worry about the 5, but I know that either the tangent of theta equals 0 or the tangent of theta plus 1 equals 0. So again, if I apply my arc function, okay, which is what you're doing mathematically, theta is the arctangent of 0, or let's see, subtract 1 from either side here. So I have tangent of theta equals -1, and then I can do arctangent. So theta is the arctangent of -1. So it's asking me where on the unit circle is the tangent -1. Now that's a little bit harder to do because you don't get tangent given to you on the unit circle. But remember, tangent is the sine over the cosine. And for that to equal 0, that implies that my sine was equal to 0. So basically, when I go over here to look at the unit circle, I want to look at where my sine is 0. Okay, so my sine is 0 at 0 and at pi, which you get when you rotate positively. If you rotate negatively, you would get negative pi. Now here again, this is where you've got to be careful, guys, because you were told your answers need to be between negative pi, including negative pi, and pi. So my answers here are going to be theta theta equals 0 and negative pi. Yes, I know it is also at positive pi, but notice in this interval, positive pi is not included. So be careful. Be careful. And then to think about where the tangent is -1, to be 1, that means you got the same value for the x and the y. We have the same value for x and y. Let's see, where does that occur? At pi fourths, 3 pi fourths, and we want it to be negative, so I need the different signs. So that's going to be 3 pi fourths, or at negative pi fourths. Yeah, it's 7 pi fourths, but remember you got to be within that interval, so be extra careful. So my answers here are, for this side, is that theta equals positive 3 pi fourths and negative pi fourths. Negative pi fourths is the same as 7 pi fourths, but that doesn't fall into this interval, so you have to be careful. You got to look at it from the positive and the negative, so be extra careful. Pay attention. Okay, 2 more. 16 says between 0 and 2 pi. Okay, so we're using 0 and 2 pi. 0 is included. The pi is 2 pi is not. Okay, and again, they want it in terms of radians. And we have 2 sine squared theta equals 9 sine theta minus 4. So the first thing I'm going to do is get this thing equal to 0. So I'm going to subtract 9 sine theta and add 4 to either side, so that I rewrite this as 2 sine squared theta minus 9 sine theta plus 4 equals 0. Now guys, that should remind you of something from your algebra days. That should look like 2x squared minus 9x plus 4 equals 0. It's a good old basic quadratic. And we typically solve quadratics by factoring. Okay, so I would have, if I factor this thing, 2 sine theta and sine theta, and then I'm going to use 4 and 1, and they are both negative. Okay, so then, whoops, sorry about that. We know that either 2 sine theta minus 1 equals 0, or sine theta minus 4 equals 0. So then I have to solve for sine theta, so I'm going to add 1 to either side. I have 2 sine theta equals 1. Divide both sides by 2. So sine of theta equals 1/2. So again, if I use the idea of the arc sine, I'm asking myself, where on the unit circle does the sine equal positive 1/2? Where on the unit circle does the sine equal positive 1/2? Okay, so let's think about this, and let me get this erased where we can not have so much mess up here. Okay, so sine corresponds to the y, and we want it to be positive, so it looks like that occurs at pi sixth, and also at 5 pi sixth. It's negative there and negative there. So my sine is positive 1/2 at pi sixth and 5 pi sixth. So theta equals pi sixth and 5 pi sixths, which is between 0 and 2 pi. And then I'm going back up here to solve this other one. Okay, so if I add 4, the sine of theta equals 4. Again, using the idea of the arc function, we're asking ourselves, where on the unit circle does the sine equal 4? Guys, it doesn't. Okay? The sine has to be between +1 and -1. Even if you try to plug that in your calculator, it's going to give you an error. Your sine value has to be between 1 and -1. Okay, it can never ever be 4. So that piece has no solution. So ultimately, your solutions are pi sixth and 5 pi sixth. All right, question 17 gets you really into Unit 8, which deals with law of sines and law of cosines, which are also formulas. So you're going to want to have those nearby. This one says, two airports are located at the points A and C shown in the figure below. Each of the airports locates an airplane at point B and measures the angles of elevation to the airplane. Given the elevation angles in the figure and that the two airports are 743 meters apart, what is the distance in meters from the airport at point C to the airplane? So we're trying to figure out the distance from airport C to the plane. Here's the plane. So we're looking for this distance, which is really, in terms of the way we would label a triangle, would be side A. And this is side B. And this is, whoops, sorry. Got my letters wrong. Okay, remember the sides are labeled based on the angle opposite. So angle A, angle C, side C, angle B, side B. Now, one of the challenges is deciding whether to do law of sines or law of cosines. Well, if you look at this picture visually, you have an angle and a side and an angle. When you have angle, side, angle, you can use law of sines. I'm ultimately looking for side A. Okay, this is the one we're looking for. So I would have side A compared to the sine of angle A, and I know side B compared to the sine of B. And again, thinking about what I know in this problem, I know angle A, I know side B. I need one other piece of information. Well, A is what I'm looking for in the problem. So I should be able to calculate side B, or angle B, excuse me. And guys, you can do that. We know that a triangle has 180 degrees. And so I know that angle B is going to be that 180 degrees total minus angle A minus angle C. So that's 180 degrees minus 77 degrees minus 82 degrees. I'm going to use my calculator. 180 minus 77 minus 82 equals 21 degrees. So angle B is 21 degrees. And that gives me enough information to plug into this ratio for law of sines. Okay, so I'm looking for side A over the sine of 77 degrees equals side B, which is 743, over the sine of angle B, which is 21 degrees. Guys, one of the things that is like super duper 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 important when you're working this problem is notice that all of your measurements are in degrees. Your calculator has to be in degree mode when you do these calculations. Otherwise, you will get the wrong answer. You got to be in degree mode. All the measurements are in degrees. Okay, we're trying to solve this ratio. So we cross multiply. A times the sine of 21 degrees equals 743 times the sine of 77 degrees. Now I'm ultimately trying to solve for A, so eventually I'm going to divide by the sine of 21 degrees. So I have side A is 743 times the sine of 77 degrees divided by the sine of 21 degrees. And guys, at that point, this becomes a calculator problem, but I need to be careful, and it doesn't indicate how to round here, but on the test, it is multiple choice, so you'll kind of know how to round. So we're going to plug that into my calculator. We're going to do 743 times the sine of 77, get the answer, divide that by the sine of 21 degrees. And I get that side A is 2020.149846. If I'm asked to round to the nearest whole, that would be 220 meters. Again, it doesn't indicate in the problem how to round. However, on the test, it's multiple choice, so you'll be able to tell. And lastly, I believe the last problem is Heron's formula, where you're asked to find the area of this oblique triangle. It's oblique because you don't have a right angle. And Heron's formula, again, is one of those formulas you're going to want to have nearby, is that the area of an oblique triangle is the square root of S times S minus A times S minus B times S minus C, and S is defined as A plus B plus C, all divided by 2. Now, since your angles are not labeled on this particular triangle, it really doesn't matter which one's A, B, and C. So we're going to say this is A, this is B, this is C. So the first thing I'm going to do is I'm going to calculate S. So to get S, I've got to do A plus B plus C, all divided by 2. So I'm using my calculator. 14 plus 16 plus 12 equals 42. And 42 divided by 2 is 21. So S is 21. And so then I'm going to fill in, again, plugging and chugging into my formula. So I have A equals the square root of 21, that's S, times 21 minus 14 times 21 minus 16 times 21 minus 12. Now you can do this any way you want to. I tend to simplify it first, so I'm going to go ahead and do those subtractions. You can either do them in your head or use your calculator. So I would have 21. 21 minus 14 is 7. 21 minus 16 is 5. And 21 minus 12 is 9. Then I'm going to do the multiplication. So I have 21 times 7 times 5 times 9 equals 6,000 615. Okay, did this say about rounding? It does not. Okay, so then we may want to try to simplify our radical if possible. It may be that the answer is given in decimals. Let's see, 6,615 is 5 times 1323, and that is 9 times 147. Let's see. And 147 is 3 times 49. See, so 9 is a perfect square, 49 is a perfect square. So I'm going to have a 3 and a 7 outside and a 15 inside. Okay. So we have exactly, it's 21 on the square root of 15. Now, if you can do a decimal, you just take the square root of 6,615, which gives me an approximation of 81.33265027. Again, the questions on the test are multiple choice, so you'll be able to tell whether you need to simplify the radical or whether you can just simply plug it into your calculator. But guys, again, let me stress to you, write down your formulas, print the formula sheets, whatever best works for you. Have your unit circle nearby, and a calculator and lots of scratch paper.